Okay, welcome. This is Unit 5.1, Algebra 2. Today we're going to be talking about functions and inverse functions and how they look. First off, you'll write a function f of x, inverse function f negative 1x. It doesn't mean that it's a negative exponent, that's just how we note inverse function. Now I'll show you something kind of cool about these. Is, for example, on the function, we might have, and I'm just going to make these up, the x values, the input values as, let's say, negative 2, 0, and 3. And the output we find is 5, 4, and 2. Okay, so that's your x value and your y value. So our domain for this one would be negative 2, 0, 3. So sorry. That is my phone. The range would be 5, 4, 2. Okay? But here's the cool thing, and it's a way that you can verify that it's an inverse, is that this being your x value, this being your y, they're flipped on an inverse. So the input would be 5, the output would be negative 2. See how this was negative 2, 5? That's going to be 5, negative 2. So this one would be 4, 0, and 2, 3. Our domain would end up being what was in the range of the original function. And the range will end up being what was in the domain of the original function. So that's how you can verify that they're inverses. Find the inverse using order of operations. Okay, here's how we do an inverse. This is how we get the equation to cause the domain and the range to flip around. Using order of operations. If I were to plug a number in here, I think, what would I do first? If I plugged in, let's say, 1. Or let's make it something nice. Let's go with 2. Okay? So if we plug in 2, the first thing we would do is we would multiply by 3. That would give us 6 minus 2 then. Next thing we would do is we would subtract 2. And we would get 4 as our answer. Okay? So now to do the inverse, to find what the inverse is, we invert their order and do the opposite. It's like when you're solving for the x and I have to go up the PIMDAs. Now you're going to do it backwards and with the inverse operation. So instead of subtracting 2, we're going to add 2. So we take x plus 2. Now, instead of multiplying by 3, we would divide by 3. So we would have x plus 2 divided by 3. Now, let's plug it in and see if we get it. Remember, our x here was 2, and our output was 4. Okay? So if we plug in 4 as our input, just to verify that we're getting an inverse, 4 plus 2 is 6, divided by 3 would equal 2. Ta-da! So that's how you can get it using order of operations. Pretty awesome, huh? Okay. Well, let's verify an inverse. So, how we just discovered that 3x minus 2 became x plus 2 over 3. We should verify, which I just kind of did with you, by plugging things in. Always verify it. So we plug in 0, 0 times 3 is 0. 0 minus 2 is negative 2. 2 times 3 is 6, minus 2 is 4. 4 times 3 is 12, minus 2 is 10. 6 times 3 is 18, minus 2 is 16. Pause the video if I'm going too fast. So now when we plug in negative 2, 4, 10, we should end up with these inputs. Negative 2 plus 2 is 0, 0 divided by 3 is 0. Got it. That one checked. 4 plus 2 is 6, divided by 3 is 2, check. And 10 plus 2 is 12, 12 divided by 3 is 4, check. I'm not even going to bother with the last one. Okay? Find the inverse using an equation. Okay, this is really cool because all you do is you bring back in y being, for f of x, 3x minus 2. And now, y was the creepy dude. Guess what? Oh, we just switch things around. Now we're going to make x the creepy dude. So, draw our line, go up our PIMDAs. Get x alone this time. First thing we do, what's being added or subtracted over here to the x? It's being subtracted. It's 2, so now we add. Plus 2. Y plus 2 equals 3x. Still going up the PIMDAs, what's being multiplied or divided by the x? It's multiplied, it's 3, so now we divide by 3. Y plus 2 over 3 equals x. Now our last thing is to exchange our x and our y, so we rewrite as x plus 2 over 3 equals, and switch it back to f of x, the negative one up there showing it's an inverse. Okay? Now on a graph, it's pretty cool to see this. Wait until you see this. This is so awesome. So if we go back and we go to Algebra 1 skills, it crosses at negative 2, has a slope of positive 3 over 1, you would have it graphed something like this. Forgive me, I don't have a ruler out here, so I'm not going to try to do the line thing, because it's more valuable to do this other anyway. Now, x plus 2 over 3, we want to switch to mx plus b form, so it would be 1/3 x plus 2/3 y, or I mean plus 2/3, and it equals y. That is the inverse. Okay, so we go to approximately 2/3 on the y-axis, and we rise by 1/3, and we go right in there. That's not the easiest thing. Actually, it would cross right on that dot. That's not the easiest way to graph that one, so I would be inclined to go back to my points and go -2, 0, 4, 2, and 10, 4. And here's what you might notice. Here's 10, 4, and here's 4, 10. Ha-ha, something's happening. Here's 4, 2, and here's 2, 4. Maybe you're not really seeing how cool this is, guys. But how about if you draw in the line that is y equals x? Look what happens. Y equals, I want it in color. Okay. If we draw in the diagonal line y equals x, these are straight across from each other. Straight across. In other words, if you could fold the graph on y equals x, the inverse would land on top of the original equation. Isn't that cool? So visually you can show it that way, and I want to see it that way this week. I want to see it. That is just, it's so, I hope you guys really enjoy math. This is just so cool. Okay, in real life, real world inverse. If you were driving, had a 100-mile trip, and you were trying to figure out, okay, how much distance do I have left if I've driven for 1 hour? Okay, so you might go 100 minus 50 times 1, and you'd find out, oh, I have 50 miles left. Because I'm driving 50 miles an hour, I know I have another hour. But let's say that you don't want to know the distance, you want to know the time. We'll just switch it around and get the inverse. And one thing I should say, in real world, we should write d of t, showing that the distance is dependent on the time. Now in your inverse, let's switch it around. D equals 100 minus 50t. Subtract 100 from each side. So we get d minus 100 equals negative 50t. Now we're going to divide by negative 50, so we get I'm going to put the whole number in front like we do with the imaginary numbers. So negative 100 over negative 50 would be a positive 2 minus d divided by 50 equals our time. Now this time is dependent of distance. So now we might say, oh man, we've gone 50 miles. How much time do we have left? 2 minus 50 over 50, that's equal to 1. And we would find, oh, we just have an hour left. 2 minus 1 equals 1. Okay? So that's how you can use it in real life. We'll come up with some other examples in class too. See you in class.